Okay, guys, we are dividing polys by monis. Let's go for it. This is page 10 in your class notes. So again, I'm starting to do the class notes on my video and then the homework to just reteach if you need it. It's always good to get a refresher. So let's go for it on page 10. If I think about this whole idea of dividing a polynomial by a monomial, remember monomial is when you have one term, and that could be 5. It could be 5x, right? It's just a one term, and poly is more than 1, right? Greater than 1. Okay, so when we are dividing polys by monomials, we have to make sure we divide each term in the numerator. Remember, the numerator is on top by the term or the monomial in the denominator, which is downstairs. So this is a two-part problem. You're going to have exponents, so you have to make sure you remember your exponent rules. They're never going away, so if you don't remember them, etch them into your brain, sing a song about them, create a poem about them, create a poster or something. Our quotient rule tells us this. If you have x to the a, and you're dividing it by x to the b, you have to make sure that you subtract the actual exponents when you have the same base. Subtract the exponents to get the final exponential answer. So here we go, the first example. So it's really helpful to rewrite these when you're first learning this as two different division problems, if you think about it that way. So this could be written as 8n squared over 4n, because that's this part. Now, let's just deal with this part. It's a subtraction problem, so hold on to your operator, and then you're dividing 36n by 4n. Notice if it's a denominator, it should be common denominator because it's only one thing. So make sure that that is the actual denominator. Okay. So if I look at this now, I have something I can do. I can start simplifying. So I know that 8 divided by 4 is 2. I could also think about 4 goes into 8 2 times. I could basically cross simplify if you think about it. And then I have n squared minus n to the first power, which is just 1n. So I'm going to end up with 2n, okay? Here, let's just look at this before I write the answer. I have 36 divided by 4, which is a nice, neat problem. So 4 goes into 36 9 times. And n divided by n, well, anything over itself is 1. So I get to cross out my n's. They cancel each other out. So what I end up with, I don't know if that was the neatest way I could have done it, but sorry about that. But I end up with 2n minus 9. Okay. Now let's go to the second example. So I could, in fact, rewrite this, which I'm going to. I have negative 14x to the 12th, y to the 5th, over 7x squared, y squared. And I'm adding it to 7x squared, y squared, all over that same denominator. Okay. Now, I'm hoping that I can start canceling some stuff. Well, let's just start to cancel. So y squared minus y squared, done. X squared over x squared, oh, done. Oh, wait a second. This is awesome. 7 divided by 7 is nothing. Basically, it's the same term on top of the same term, the whole thing. It just cancels each other out. So really, I'm just left with this term over here. So if I think about 7 goes into negative 14, so 7 goes into 14, negative 14, if you think about it, 2 times. Trying to write that neatly. Then I have, so I'm going to maybe, let me go ahead and write -2. Then I have x to the 12th divided by x to the 2nd, and I'm going to subtract 2 from 12, which is going to give me x to the 10th power. Now I have y to the 5th, and I'm going to divide y to the 2nd. So I have 5 minus 2, that's y to the 3rd. Now, is this my final answer? Because we just said that these cancel each other out. Is this the final answer? Well, it's actually not, because this is not 0. Anything over itself becomes 1. So that whole thing is 1. Okay? Let's go down to the you try. Let me make sure I can see it all. Okay, let's go for it. So again, I'm going to keep writing it like 2 different problems here, just so you really see. You always want to make sure that any polynomial on top, right, if you're combining different terms with adding or subtracting them and then dividing it by one thing, that this denominator has to go into both parts. So again, I like rewriting it like this. Now you can begin however you want, but I think of this as, well, I see 9 over 3. 3 goes into 9. 3 goes into 9 3 times. 3 goes into 6 2 times. So now I have 2x, because I don't have anything else, plus 3. Okay, so I can rewrite this if I want again. 10v squared plus 5v over 5 minus 15 over 5. Okay, again, I like writing it out like that. Well, I'm going to start over here because I think this is a neat one. 5 goes into 15 3 times. 5 goes into 5 1 time. So basically I have v. 5 goes into 10 2 times, and I have v squared. So now, let's see what I have left over. I have 2v squared plus 1v minus 3. Voila. I rewrote them, so let's do it. So you can start anywhere. Let's just start from the first one. Well, 8 over 1, if you think about it, is all just 8, right? And then I have a cubed minus a linear a. So 3 minus 1 is 2. So 8a squared. I tended to that. Bink. Now I have -2 over 1, so it's just -2. And then I have a squared divided by a, which is just, well, an a. And then I have a over a is just 1, if you think about it. So I have 5 times 1. So it's really just 5. Just add a 5. Okay. Now I have 40x squared. And by the way, you don't have to rewrite it each time, but I am, because I think it shows it better. Because sometimes when you don't show your work, you can get a little messy, okay? Well, I already see something pretty awesome here. I have the same term on top and bottom, so go ahead and cancel those out, but don't forget that means 1. Then I have 40 divided by 8, so 8 goes into 40 5 times. So I have 5, and I have x squared minus x to the first, which is x, and I have to subtract 1 from that. Okay. I'm going to end there, but again, my biggest advice would be to keep rewriting it each time, so you really can see if you make an error or not, okay? So those are the class notes. Again, you'll see all the answers. If you wanted to continue with these, you can, but look at the answer key. But let's go ahead and look at, let's see if there's anything else here we should do. Those are some good challenge problems if you want to do them. But let's go on to the homework. So this is now homework 4. Okay, so I need a sharper pencil. That's a little sharper. So here we go, homework 4, dividing polys by momies. So if I look at the first one, and again, well, at least I don't have to rewrite this one. So let's go for it. I know that 5 fits into 25 how many times? 5 times. And then I have x to the 5th minus x to the 2nd, which is x to the 3rd. My answer is 5x third, to the 3rd power. Okay. Does 3 fit into 48? Well, it does. 3 fits into 48 16 times. That's a good one to remember. So I have 16, and then I have, oh no, I have a negative. Oh no, I have m to the 3rd minus m to the 4th, which means 16m to the negative 1. Now, think back to what that means. If I have 16m to the negative 1, 16 stays on top. Don't ever put this coefficient downstairs. It always stays on top. It is 16, 16. But this, remember, m to the negative 1 power, or first power, means what? 1 over m. So what this turns into is 16 over m. Okay. Number 3. Ooh, I've got lots of x's and y's and z's. Well, here we go. Negative 5 goes into 15 3 times. So maybe I should rewrite it over here. So that becomes a 1, 15 becomes a 3, because 5 out of 15 is actually a 3rd, and I have a negative 5. So I have a negative 3rd, and now I have some, oh, this is heavy duty. Now I have x to the squared minus x to the 4th. Well, I'm dividing, but I'm subtracting the exponents, which leads me to get a negative exponent again. And I have 3 minus 2. Phew, at least it's not negative, right? Y to the 1st. And then these become 1, so they cancel each other out. So I can further simplify this because I don't want to have negative exponent, right, in a final answer. So let's think about this for a minute. My fraction here stays a fraction. So you could think about this. You could rewrite it like that if you want, right? Don't do any flipping of this just because there's a negative exponent, because that is attached to the x. But now the x, what do we do with the x to the negative 2nd power? Well, remember, if it's already in the basement, you want to bring it upstairs. If it's negative up here, you want to bring it downstairs. So let's tend to that. That becomes x to the 2nd power. And now we have a y, which was already upstairs. Okay? Now, you can keep your 1 here if you want, but in the best, oh. Well, isn't that funny? It didn't, oh man, it's asking me to log in again. That's a bummer. Please hold. Oh. Okay. That's a big bummer, but anyway, what I was saying is that if you have a negative 1 there, you don't have to keep it there. You can just get rid of it, right? So this, if I had an eraser, then I could just do that. So the final answer is negative y over 3x squared. Okay, moving right along to number 4, before my computer explodes on me. This is when I'm going to rewrite these as 2 different division problems. I do, again, highly recommend that. So I'm going to start with this one. 3 fits into 12 4 times. 3 fits into 15 5 times. So now I have 5x, because that's what's left over, minus 4. 12k squared over 4k minus 20k over 4k. Okay. That's funny. Let's go for it. 4 goes into 12 3 times. K squared divided by k is just 2 minus 1. Okay. K divided by k is just 1. 4 goes into 25 times. 3k minus 5. Okay. 6a squared over 3a squared plus 21a over 3a squared. And here we go. So, oh, that's kind of cool. A squared cancel a squared. 3 goes into 6 2 times. So I just have a 2. That's kind of fun. This is when it gets kind of fun, but I know that's kind of dorky for me to say. Oh well. Then I have, oh, this is funky. 3 fits into 21 7 times, right? So that's straightforward. But then I have this sticky situation here, which is a to the first divided by a squared, which is a to the negative first power. I'm going off the page. Can you see it? Okay, remember what a to the negative a to the negative first power means 1 over a. Okay, so I, in essence, have 7. And then I have the 1 over a. Well, that becomes 7 kind of times 1 over a, right? 7 over a. Number 7. 2y cubed minus 18y to the squared over the same denominator, okay? So now these cancel. 3 minus 2 is 1y minus 2 goes into 18 9 times. These cancel each other out. Oh, yes, that's pretty straightforward. I've got a linear here. Okay, great. 8. And I'm going to rewrite this one too. 4b cubed over b minus 3b squared over b plus v over v. Well, I already know that v over v is 1. Okay? Don't forget about that 1 though, remember? And then I have 4 v squared, 3 minus 1. Minus, hold on to the 3, v squared minus, got a 1 here, which is just going to be v, plus my constant right there, 1. Okay. I think I'm going to do a couple more, and then I'm going to sign off. You can look at the answer key. Hopefully you're getting it's the process that I care more about than anything else, that you should care more about too, so you can apply all this to new problems. So I have separated these out, and let's go 2 goes into 6 3 times. I don't have any other C's or D's down here, so I'm going to stick with my C to the second D. Okay, sure, that's the second. Then I'm going to subtract. 2 goes into 14 7 times. So I'm going to put my 7. And then I have no other variables down here. So I get to hold on to the same combo of there. And then I have 2 over 2, which becomes 1. And then I have d to the 3rd power. Sweet. Okay. Let's see. I'm going to end there. Look at the answer key for the rest. And if you get a lot wrong, do me a favor and really separate them into different expressions like I did over here. This will get challenging, especially if you go down to, like, because I know you're doing the odds. Like if you go down here, and just keep in mind that these numbers are chosen on purpose because the bottom coefficient is probably going to go neatly into each of the coefficients up top. Okay, so I wish you well. I have spoken.